this video, we're going to revisit the modeling wizard. Let's go to a triangle group called CS5, this one here, CS5. Let's open it. Let's go to data sets. Actually, I've designed these models before, so I'm just going to delete these models, wizard models, because I'm going to do it again. Go to data sets, and if you look at the data set, triangle PLI, there's no exposure, but there's an inflation vector which is being used. And this inflation vector by calendar year I've called base inflation. Let's look at the exposure inflation premiums tab within the triangle group, just here. Open the base inflation vector. And you'll see these are inflation rates which represent the CPI in the economy. This is the state of Queensland in Australia. And these are inflation factors which are the cumulative inflation rates. So if we apply these inflation rates to adjust the data, then any trends, any subsequent trends in the data in Australia would be called superimposed inflation. It's the amount of inflation above economic. I guess in the States and Europe it might be called social inflation. If you go to the data sets and now open the data set itself, you'll notice that the triangle is actually a trapezoid. These incrementals here for the calendar year 70 to 79 were actually missing, but these incrementals here were not missing. And in fact, you notice that the 87 calendar year represents the most recent data. If you were going to model this triangle cumulatively, you would only start in 81, and you'd miss out on all the most recent data or the most recent information. Okay, let's close it. Before we do, you'll also see that there's a tab called Selected Exposure Inflation Premiums within the triangle itself. And again, you've got the exposures and the inflation rate, so you can see the whole data set. Let's close the triangle. Let's go to, or you can either, well, we could go to Models tab or leave it at the Data Sets tab. Suppose we go to the Models tab, go to PTF. There's the wizard preferences, the Psi-P or WP. If you now click on it, it's under the Triangle Group tab. There's an option, Wizard Preferences. With the right button, you should have selected the Multiple Models Constraints wizard. Not that or any one of the others is actually selected, make sure that one is a selected one. Now run the modeling wizard, and you'll see that it actually comes up. If you go to load model, you'll see that there's an M1, M4, M6, and you might remember that M6 equals M4. So you've got a sequence of 3 models that the wizard created. It created M1, did some testing, then did some testing on M1, saved it as M4, and M6 is just a copy of M4. Okay. If you now go to load the current model, there is M6, which is, let's load M1, and in the logbook compare the two. Now, if you look at the number of observations for each model, it's 90 under N, N here and N there. Now, the BIC, excuse me, the BIC for M1 is better. It's a better statistical model. Okay, so what we do now is we want to run M4, but in a new window, M6. So we go to load, where it says M with the upward arrow, load. With the downward arrow, load in new window. So we're going to load model in new window. So we still have our model M1 sitting there in a window called PTF1. And now we're going to load M4, M6. It doesn't matter which one you select. They're both the same. M4. And now tile vertically, minimize other types, so you're just looking at the model displays. And you'll see that, what's the differences? M4 my guess is it's got some additional parameters. Can you see? Now, but given that this parameter is equal to that parameter, the two parameters should be the same, the number of parameters. Let's check that. It should be approximately the same. So if you go to the logbook, with the right button on the logbook, the two logbooks will come up. So, and choose all. Remember, with the right button on the logbook button. Let's put one underneath the other. So if you look at the number of parameters, 5.5, actually I was wrong, versus 6.8 for M4. So M1 actually, which is really the better model, I guess one reason it's better, it's got fewer parameters. Sorry, it's the other way around. It's M4 which is better, right? It's got a lower BIC. I hope I didn't confuse you before. It's M4. I did say usually if you have the sequence M1, M4, then M4, if it's different to M1, it's usually better. So it's the M4 which is actually better. I mean, statistically. Okay, the number of parameters is actually the other way, so I need to correct myself. No, it's M4 that has more parameters, but its BIC is still lower, okay? Which means its S squared is probably considerably BIC, let's look at S squared. The S squared is about the same, 0.389, 0.0344. Okay, but we also have a heteroscedasticity, so it's hard just to judge by the S squared. That's kind of the lowest variance. We do have a heteroscedasticity. If you close the logbook and you look at the model display by development years, we've got heteroscedasticity that you discussed when you looked at the triangle group CS5 in a previous video. Okay, so what are the differences in the models when M4 is better? M4, the huge calendar year trend goes to 84 only, whereas in M1 it goes all the way to 85, and M4 also has an increase in the accident years here. M1 only has the decrease, and M4 is better statistically. Now, any time the wizard sets the trend to 0, it's always worthwhile to actually estimate the trend. The trend was actually estimated by the wizard, using a model, and then it set the trend to 0 because it was insignificant. So any time a wizard sets the trend to 0, it's a good idea to go back and estimate it. And it's also always a good idea that once that in your selection between two wizards models, you also need to test them. So let's look at the residual graph. So with the right button, go to all. And now tile vertically, so right button on the residual graph button, right button of your mouse with the three diamonds, choose all, and then tile vertically, minimize regression tables. And let's look at it by calendar year. Now, M4, which is better, only has a huge calendar year trend to 84, and then 0. If you look at M5, M1, don't know where I got M5 from. If you look at M1, notice that it says the name of the window is PTF M1 Run 1. If you look at a corresponding M4, you'll see that it's PTF, a second window, number 2, and the model is M4. So going to M1, it seems like since 84, even though you measured a high trend till 85, from 84 to 85, doesn't it actually seem to go down? So let's go to M1 and add a parameter from 84 to 85. Okay, remove the 0. So let's do that, okay, and estimate. Let's just do that for a change. And actually, that trend is significant. That trend is actually significant. And now the residuals, in fact, also look better. So it's a significant trend. If you had one from 85 to 86, estimate, you'll see that there's no significant change between 85 and 86. So if you click on O now, that parameter will be removed, and now we're left with a 6%. And let's save that as, well, it's good one, which I've already saved before, but you'll have to do it. Call it good one. Yes. Let's look at the logbooks now. So the residual graphs using M1 suggested that maybe the high trend does stop at 84, which corresponds to the model M4. But then when we estimated that trend, we've got this 6.47%. If we look at the logbook now, that's for M4. Let's highlight good one and look at the logbook LOG. It is now, the BIC is, well, it's still about the same as, it's a bit higher than M1, and it's higher than M6. Okay, so the BIC, in fact, for good one is higher, so we're not really doing any better in terms of, improving the statistics of the model. Okay, all right. So why don't I now go to M4. Let's play around a little bit with M4. And now actually estimate the trend from 84 to 85. Remember, if the wizard sets it to 0, let's estimate it. Now, the trend is not significant, but given there's quite a bit of process variability in the data, you could argue that why don't we stick with that trend? I mean, a better statistical model might actually be zero trend, but in the absence of any other information, you could argue that because there's quite a bit of process variability in the data, and we want to be sort of on a conservative side, we could assume that the trend in the future is a random number from a mean of 4.9%, and that's standard deviation. So let's save that as good 2. Now, how does good 2 look statistically, just in terms of BIC? Good 2, it's 88.1. Okay, it's a little bit higher than M4. If we now run good 1, if we now run M1, just to look at the whole situation statistically, we find that good 2 hasn't got the lowest BIC. It's comparable to M4. Now, what's the difference between two? M4 had a 0 trend in the most recent calendar years, and good 2 had a trend which is not significant. It was designed from M4, but we'd like to act more conservatively and assume that the future trend, we don't know it really well, it's kind of non-credible, and it's a random number from a distribution, a normal distribution with a large standard deviation. So what we could do now is load each and compare each. So with the right button of your mouse on the load model and click on all, and let's select good 2 and M4, isn't it? Was it M1? Good 2 and M4 here. Okay. M4. So now tile vertically, minimize other types. So we're just looking at the model displays. These are the two comparable models. The only difference is instead of estimating a 0 trend there, we estimate a trend that is insignificant, and to me this is a much more conservative approach. So what we've learned here is you test your wizard models. Okay, over here we compared M1 to M4. M4 was better statistically. We did some variations on M1. We didn't really do any better, but the main variation on M4 is instead of setting that trend to 0, we've got a trend there that is non-significant, but at least we're acting quite conservatively by saying we don't really know the trend if you try and validate this model, it's going to be a bit hard because this trend subject to a light standard deviation is going to be quite unstable. But anyway, let's remove a couple of years, say 86 and 87, just to see what the validation applies like. And in fact, the numbers actually increase because the trend estimate actually increases a little bit. Otherwise, we're not doing too badly. Well, it's pretty unstable estimate. I mean, it's got a large standard deviation, so as you remove data, it will actually, change. And over here, it actually increases, which means the more recent years are a little bit lower. Well, these 2 years are a little bit lower than these previous years. What are the other options for the wizard? There are the sequences. If we go to the user's guide, if you try and search for wizard, you'll eventually reach page 355, okay, of the user's guide, appendix 3. And what happens, in fact, when the wizard saves model M1, it also looks to see if a particular condition is satisfied. The first condition it actually looks at is this condition. In the model M1, what if in fact the gammas are increasing and the iotas in the more recent calendar years are in fact decreasing? Now, you might remember that we've got this what's called slight identifiability problem. Let's look at it in our PowerPoint display. Let me search this. If you've got a triangle with a minus 20% development year trend, and then along the calendar years you're at 15% and 10%, then that's the same model as having minus 5% along the development years, 0 along the calendar years, 25% along the accident years. And that's the same as having minus 30 along the development years and 25% along the calendar years. Why is that the case? We know that any calendar year trend projects along the other two directions, but also accident year trends project along the calendar years. So we know that, say, a trend that way along the calendar years is equivalent to the same trend along the development year, accident years, and the same trend along the development years. So if you take any triangle and you create a 15% trend along the calendar years to get a second triangle, it would be the same as if you had 15% along the development years and 15% along the accident years. Now, if I subtract this development year trend from each side of this equation, let's suppose that was 10%, say, and that's 10%, and that's 10%. Well, that's equivalent to having minus 10% along the development years, because I'm subtracting 10% from each side of this equation, 10% along the calendar years, which is equivalent to now just 10% along the accident years. They're equivalent. And as a result of that, when you model data, either manually or using the wizard, you might come to a situation where you have a positive gamma, positive development trend in the most recent development years by a negative iota. Alternatively, what the wizard does then, it might actually set the iota to 0, and as a result of that, you'll get a negative gamma. So try something else, and then it might come up with a sequence. So if you get the sequence, if you get the sequence now, M1, M2, M6, you'll find out that most likely M2 statistically is much better than M1, but it's also just much better in terms of interpretation. Instead of having a model that has a positive gamma and a negative iota, it doesn't make sense. You'll have a model that'll have a negative gamma, negative development year trend, and either 0, slightly positive iota. Okay? There's another condition. In other words, if M1 satisfies that condition, then the wizard will design a model called M2. What if you have the following situation? What if instead you've got iotas that are going up and the alphas are all going down? Okay, what the system will do then, that's model M1. It's a feature of model M1. What it might do, that first, it'll set the iota to 0, model the alphas, set up constraints on the alphas, and as a result of that, when the system goes back, the wizard goes back and models the iotas, because the alphas are constrained, as a result of that, it's unlikely, it's very unlikely you'll have increasing iotas. The iotas will more or less look like this. Okay, maybe they'll go up a little bit more recently, or they'll be around 0. Okay? Or you will have increasing iotas, but at the same time, the alphas will be sort of constrained to be around the same level. Okay, so then you get the sequence M1, M3, M6. Sometimes instead of M6, you see M5. And M5 will be different to M3, M2, M4. When you see that, it's very unlikely that M5 is going to be better than the M2, the M3, M4. But anyway, check it and test it. So there is another reason for it should be able to set constraints. Another reason for setting constraints, or the system having the capability to set constraints between non-contiguous parameters, is that if the alphas are doing that and the iotas are doing, sorry, what did we have? We had it the other way around. We had the alphas doing that, alphas, and the iotas doing that. We constrain the alphas to do that. So the beta and the iota are constrained, and then the iotas might behave this way. They'll be increasing. Okay, and that's a good reason for setting constraints. It's actually the same thing with when you go with the other directions, when we had the following, when the M1 would have this kind of structure. Also, we might set constraints on the iotas, setting them around 0. We constrain them to be around 0, and then we design a model that has a negative. But you know, the resultant trends will be very similar. It's really the resultant trends that are important. And there is, if you go back to the system, if you click on this button here, resultant trends, it's on the right, sorry, it's on the left of the diagnostic tools button, which is the, the magnifying glass. You can go to development period direction, resultant trends, it's the gammas plus the iotas. The accident periods resultant trends, which is the sum of the iotas plus the differences in alphas. And these are just graphs of those. Okay, looks a little bit complicated. So between these competing models, like the M2 and M1, the resultant trends will be very similar, but M2, the interpretation will be much better than the interpretation you would give to M1, where these say the gammas are increasing, the iotas are decreasing. Okay, thank you for that. Much more in the user's guide about the wizard.